When we first introduced solutions, we talked about the molarity of a solution. When dealing with solutions of ionic compounds, there is an added complexity. We can talk about the molarity of the solution or the molarity of the individual ions. Think about potassium iodide, Ki, which goes to potassium ions and iodide ions when dissolved. If we said that the concentration of the compound, potassium iodide, is 0.40 molar, then we would also know that the concentration of potassium ions is 0.40 molar, and the concentration of iodide ions is 0.40 molar. This is because, based on the balanced equation, 1 mole of Ki forms 1 mole of potassium ions and 1 mole of iodide. But now let's think about iron 3 nitrate. The balanced equation shows 1 mole of compound forming 1 mole of iron 3 ions and 3 moles of nitrate ions. So if we start with a concentration of 0.10 molar of the compound, then the concentration of iron 3 ions is also 0.10 molar, but the concentration of nitrate is 0.30 molar. Since upon dissolving there are 3 times as many nitrate ions as iron 3 ions, the concentration should be 3 times as large. This is really nothing more than a reaction stoichiometry problem. In fact, we could solve this like a reaction stoichiometry problem. We start with the concentration of the compound and then apply a conversion factor from the balanced equation. For iron 3, 1 mole of iron 3 is produced from every mole of compound. Using this conversion factor, we find a concentration of 0.10 molar for iron 3. For the nitrate concentration, we start with the compound concentration, but this time find a 1:3 ratio in the balanced equation. Thus the conversion factor has a 3:1 ratio as well. This results in a concentration of 0.30 molar for nitrate.